Okay, today we're going to see if any of these ideas about quadratics and parabolas make sense to you. We're going to use the same exact ideas, but in different kinds of problems. In this first problem, we have a kicker kicking the ball, and the defender is 6 feet away. And if you look at this equation, when x is 0, y is 2, meaning the ball is 2 feet above the ground when the punter kicks the ball. So first we go to y equals, press that, and these places for equations come up, and we go ahead and type in our equation, which is over here to the left. And so we'll type in negative. Now don't use the subtraction key, use the negative. Subtraction key is next to the 6, but the negative is below the 3. And right in here, you'll see the key presses that I do. So negative 0.01, even though that first 0 is not necessary. X is here. Then we're going to square it. Then we're going to add 1.18, and then just the x, and then add the 2, and press enter. If you press graph, you may get something like this. Well, if you look at this key called window, you'll see that the window goes to the left 10, to the right 10, down 10, and up 10. Go back to the graph. Well, this is 10 feet. And if a punter can only punt the ball 10 feet, they're cut from the squad. So we have to make some adjustments here. So in our window, we're not going to kick the ball backwards. So let's not have the x minimum be negative. Let's just have that be 0. The x max for feet, well, let's say that he kicks at 60 yards. That's 180 feet. Let's see if that is enough to show on our picture. Enter. And then let's show this at every 10 yards, so that's every 30 feet, just like the field is marked every 10 yards. The y minimum, I know that he's not going to punt the ball into the ground, but I need that to be negative, and you'll see why in a second. I'm going to leave that. The highest, let's say he can kick it up to 20 yards, that's 60 feet. And let's again have this mark at every 10 yards, which is 30 feet. So the x scale is left and right, the y scale is up and down. Now if I press graph, there's our picture. So what you should do, even though it's on your calculator, you need to redraw this. And for the moment, we won't know too much of this information. For now, all we know is that the point that he kicked it was 2 feet above the ground. Nothing else we can mark yet. We can draw this shape. Well, to find the maximum where this punt is, this kick, we can use the idea of a vertex. And negative b over 2a will find that vertex. Our b is 1.18. Our a is negative 0.01. So over to the left, we can see that the negative b is negative 1.18, and the 2a is 2 times negative 0.01. Working that out, we're going to get 59. So what we can then do is plug in this 59 into our calculator and see what that gives us. So what you can do is go to second and the calc, which is the trace key, and choose 1 for the value. And then you can type in 59 next to x equals, press enter, and it will give you the y value at the vertex, because 59 was the x value of the vertex. And so here we type in the 59, and this is the window that shows that calculation. Okay? There's another way to find the vertex without doing negative b over 2a. If you look at the parabola, the vertex is at the maximum point. And at second calculate, we get this menu, and there is a maximum choice. So if I press 4, I get this screen. Down at the bottom it says left bound. So here's the maximum. What you want to do is go to the left, use the left arrow, and go somewhere to the left of the vertex, and then press enter. The bottom of your screen now says right bound. So we go to the right of the vertex with the right arrow key and press enter, and now it says guess. So go back to the left, around the vertex, doesn't have to be exact, press enter a third time, and voila, the maximum or the vertex at 5936.81 feet is the highest point the ball travels. So we have the left bound, the right bound, the guess, and there it is. In the first case, we found the value and we plugged in 59. In the second case, we chose maximum to find the highest point of the parabola, the vertex. Now let's talk about the defender. He is 6 feet or so away from the kicker. So we go up to this point right here where the ball is going to be. We want to see how high the guy has to jump to block the kick. So as you can see, we still have our formula in y equals. So I'll go to second and calc. And this time, I don't want to find the point of the vertex. I want to find the point where he jumps. So again, value, choice 1. And he's 6 feet away on the x-axis, so I type in 6. And if I press enter, I get the corresponding y value on the y on the parabola. And that's the 8.72. So it's 8.72, and it says include units, and so this is feet. I know we talk about football in yards, but everything they've talked about in the question was in feet. So make sure you catch that in the equation. If the ball is not blocked, we want to know how far the punt will go down the field before it hits the ground. Well, if it hits the ground, the height is 0. So then this equation, y equals this equation, is going to equal 0. Okay? By hand, that's an issue of the quadratic formula. Now, here's the quadratic formula, but you might notice I left something out. Okay? Here's the negative b, here's the b squared, and here's subtracting the 4ac. But I didn't put plus or minus, and here's why. I know that the answer is going to be positive because he's kicked the football down the field. Well, if this bottom number is negative, I can see that 2a, a is negative, and this number is negative. I better make the top negative so that when I divide, I'll have a negative over a negative, which makes it a positive. So to guarantee that the top is negative, I need to subtract. So you have to think about how the formula works. Now when you type in this formula, I would suggest you do it in two parts. Because if you don't, you'll have these lots of parentheses and you could make a mistake. So up here is the negative b minus the square root of b squared minus 4 times a times c. And I get an answer. Then if you press the division key, the answer will automatically show up, but you want to make sure the whole 2a is under the fraction. So to do that, you have to put a parenthesis around the 2 and the a. If you don't, you'll only divide by the 2 and then multiply the whole thing later by the negative 0.01, which is wrong. So you need to package the 2a in the formula. But again, you can do this with the calculator. But this time we're going to choose 0. When is the y value 0? You choose that, and up will come a left bound. So just make sure you're to the left of the x-intercept. Then it'll say right bound. This is why I had the graph go below the x-axis. I needed to point to the right of the x-intercept. And then guess, move your cursor back to the left, close to the x-intercept. And then when you press enter, boom, you have how far away the ball lands. And in both cases, they're about 120 feet. And for you football fans out there, that's about 40 yards. Now when we talk about domain for kicking, I just chose 180 feet because that's 60 yards. True, people do kick the ball further than that, but I thought I would try that first to see if it fit the data. If they give us something like this, and they want us to interpret it, well, we know that this is x and this is y. And so 10 feet away from the kicker, the ball is about 12.8 feet up in the air. Again, these are feet values. So about 10 feet away, about 12.8 feet up. X, y, x across, y up and down, in this case up. To answer G, to find out what's going on when the ball is 30 feet up in the air, in y sub 2, I typed in 30. So you would type in y equals and type in 30, and then you'll get this red graph along with the blue parabola. And then we want to find out where these intersect. Now, there's going to be two answers. I'm going to find the one to the right. So this time we're going to use intersect. Choose that, and it'll say first curve. You'll see up here that's the parabola, F1, Y1. Press enter, just press enter, nothing to do, and then it'll say second curve, and the y equals 30 shows up. Just press enter again. So you've chosen the blue graph and the red graph. And then guess, well, for your first guess, you can move the cursor close to this intersection, and I'll find out the x value where that occurs. What you're going to do is do this again, but this time guess over here and find out the x value on this side.